you will get this simulator if you search with automated trigonometry or geometrifying trigonometry simulator in Google. You will get this in Autodesk forum. Now this is looking like jungle. First of all, we have to say this side is to represent the multiplicative form of trigonometry ratios. We have already said that A, B, C, D are 4 forms of cos theta, E, F, G, H are 4 forms of sin theta, I, J, K, M are 4 symmetries of tan theta. Theta is the seed angle which we can change from here, and we can see the glued effect of multiplication. From here we can see the construction stages of gluing, and you can see that the summations are growing, the other kind of summations are growing. We will show all these in different videos stage wise. Currently we are showing about LAOAOAO kind of things, that is a cos theta into sec theta into cos theta into sec theta into cos theta into sec theta. In this way the gluing is working, and due to the gluing effect we are getting the summation of the outputs with this color and summation of the accumulation with separate color. We will show it later. Now this is the command string with which we are representing the multiplicative form and summation form both together, because L, LA, LAO, LAOA, LAOAO. In this way we can add them and get these kind of curves. That is a summation of the infinite series or summation of the cumulative summation of these kind of expressions. We will see it, and the seed angle is shown here, which is shown here also, and construction stages are controlled with this, from the first seed triangle to the second, third, fourth. You can see here 0 to 3 how many of these of constructions are there, that you can see here. Now these are the bounding boxes. These are the bounding boxes for separate cases. We will stop these different things to avoid the jungles. First of all we will put it to 45 degree such that we can see the effect here. Now we can set it to 30 degree to check its output. Here also you can see the 30 degree, here also you can see that 30 degree is turned on. Now here we will show that our text reports are making jungles. Here every line segment has an address, and which is LA, LAO, LAOA. In that way it is written there. I am stopping these first to avoid jungles. Then I will stop the bounding boxes such that we can see the pictures more clear. Suppose here are the bounding boxes, and I am stopping these bounding boxes are stopped. Now the cumulative additions are also there. I will stop the cumulative additions such that we can get more clear pictures here. Get the cumulative summations here, and we will stop these for temporarily for this video such that we can see the clearer pictures here. We can save the DXF files in the D drive or in the current exe folder, and BMP files also here, and GIF files are also generated here. Now we can get the construction protocols like this. Suppose first triangle, seed triangle is generated with 30 degree, that is L, LA, LE. This one is the complement automatically generated. In the multiplication is gluing previous video we have already shown this process, how we can generate this first triangle. Now this is the output LA, the output is this one. Now LA, this is taken as the input, and O is implemented on that. We will get the next triangle here, that is cos theta, L cos theta into sec theta is this one. Then again a cos theta is multiplied, then it becomes here. Again a sec theta is multiplied, then this line segment is generated. Again a cos theta is multiplied, then it is generating like this. Then again a sec theta will get multiplied, it is going here. Again a cos theta is multiplied again, it is going here. In this way we can get the gluing effects, and it is repeating cycling, and in this way we are not going to get any effect here. But if we check it with lower values of angle, if we check it with suppose 10 degree, 8, 9, 10 degree, then we will see the effect that when the more gluing is done, it is turning into the circle, and it is like Euler circle where e to the power I pi is equal to 0 is equal to -1, and this kind of thing we can achieve with pure real numbers. We don't have to get any other kind of imaginary numbers to achieve these kind of things. Theta tends to 0 and power is increasing, we can get these effects, that is e to the power I theta, that kind of effects we can get. Now for the AOAOAO, that is cos theta into sec theta, for one kind of symmetry we are getting it is clockwise movement. Suppose we are not trying to get the AOAOAO, we are trying to get the different kind of multiplication of cos theta into sec theta. Suppose we are taking it is at L dn, because a b c d are cos theta, 4 varieties of cos theta, we are taking d instead of a, and n o p q are sec theta. Instead of o we are taking n here. Suppose L dn is taken. Now the picture is like this, and if we take it L dn, and if we want to see its to the power n, where n is large and theta is less, then we can do some calculus like behaviors here. Let's see, we can get a calculus like behavior here, which is like this. It is like a stair, and as we will increase the theta, we will see its behavior like this. For the dn, the behavior is like this. This is the behavior of the locked set. And interestingly, if we try to get the infinite sum for this, it will look beautiful. And it is like this. Say it is a summation of this series. Suppose the cumulative sum is taken, it looks like this, and cumulative sum of the complements is taken, then it will look like this. And as we will take the construction protocol stepwise, first triangle is generated, second gluing done, third gluing done, fourth gluing done, fifth gluing done, sixth gluing done. It is like LD, LDN, LDND, LDNDN. In this way, if we continue our summation, and if we get the summations like this, and it will start repeating here, our complements will form the pentagons, and the output line segments is going to generate this kind of shape where the seed triangle is here. And if we do this summation continuation, then we will get it is repeating on this. And if we take the perimeter of this, and if we take a multiple of that, that is the summation of the complement. Just perimeter, take the perimeter of this kind of curve, and if we take its k times, then it is overlapped k times, and the summation of the series is found. So integration is also possible with this geometry. Now for the different values of theta, we can see the different summation effects, and we can find the summation also from these curves. And it is very interesting geometry which we can see out of the multiplication of cos theta into sec theta, which is ultimately 1, but cos theta into sec theta whole to the power n is equal to 1, but the summation of LD, LDN, LDND, LDNDN in this way, that is L sec the cos theta plus L cos theta into sec theta plus L cos theta into sec theta into cos theta. If we proceed in that way, then we can get these blue colored lines, or this bluish green color of line as the summation of this series. It is very beautiful. And for this series is taken infinite times and theta is taken very small, then we can get the summation. We can check the different varieties of cos theta and sec theta in this way. Suppose ABCD is cos theta, NOPQ are sec theta. Suppose we can take it as LANNOCBZ. This is also a cos theta into sec theta effect. That is, suppose A is cos theta, NNO is sec cube theta, then again C and B are cos theta. So cos cube theta into sec theta, it's going to give us a cos cube theta into sec cube theta, which is ultimately 1, and cos cube theta into sec cube theta whole to the power n is also 1, but we can get the different geometries for the different commutation. Because it is non-commutative geometry, we will get very different kind of pictures here, and for different angles these pictures will change, and the summation of this series is going to appear as per the perimeters of these summation curves. And it is very interesting and more interesting than complex number geometries. And you can see the behaviors of this construction, and you can check the gluing effects stage wise with this rightmost slider, with which you can see like this. The summation is the continuation of the summation, like LA, LAN, LANN, LANNO. In this way the line segments are growing here, and cumulative summations are also going here. The red color is the summation of complement lines, and bluish green is the summation of output lines. In this way we will get the total summation, and if it continues, it repeats like this, we will get the integral curves like this. And this is very interesting output. For different angles its behaviors are different, and you can see the summations of infinite series. We have seen that in several cases pi are present for the summation of the infinite series. That is because this kind of power series always generate a cyclic loop if the multiplication has a repetitive cyclic nature. And if we want to avoid this summation, then we can examine the behaviors of the locked sets. If we want to check the behaviors of locked sets, then we can stop the output of summations here with the cumulative summations as no. Suppose we are taking the cumulative summations as no, and then it will show only the locked sets here. And these locked sets has also different interesting geometries. Several of these points are on a same circle. How many of different circles which are forming there, and how many of these lines are lying on the regular polygons, those things are also a theorem. And every point has a name, every line segment has a name, so we can generate several theorems out of these behaviors. And it's very interesting geometry which we get from the multiplicative behaviors of cos theta and sec theta. Similarly, there are 24 varieties of symmetries. For cos theta there are 4, for sin theta there are 4 symmetries. In that way there are 6 ratios, and for every of these ratios there are 4 symmetries. So 24 symmetries are possible, and for every of these symmetry we will get this kind of geometries. And you can check where the lines are going for every construction stage. For every theta you can check where the lines are going and how the geometries are forming. You can check all this detail, and you can also check how the whole thing is changing if the seed angles are changing. This is the interesting thing of this subject. Suppose, and for 45 degree, for value of near 45 degree, it's a very interesting story. For every kind of sequences we can get very interesting stories and interesting theorems also for these different values of theta. Suppose very near to 0 degree and very near to 15 degree, very near to 22.5 degree, very near to 45 degree, we get very interesting geometries there. And here we will show how to change the seed angles. This is seed angle, this is the position of the seed angle, say 30, and we can see the geometry here for 30 degree. We can change it from here also. You can look here, if we change from here, then these angles are changing and the whole geometry is also changing. Today we have shown only for the cos theta into sec theta. We can show these behaviors for other ratios also, the multiplicative behaviors of trigonometry ratio with different seed angles, and we can see the behavior of log set, we can see the behaviors of summation of the series, behavior of the summation of the complement, we can see the behavior of the CG of every triangle and their movements, summation of the CG also are there, and we can see the CG chains also with the different thickness, and you can experiment with these things and you can get different geometries. You can write theorems on these properties. First you can go through the theory of geometrifying trigonometry and the construction protocols, how is it followed. Then you can automatically generate your own theorems also on this whole system. You can verify it with the pen and paper also on your notebook. It's quite easy, because after you understand how to construct these geometries, it is very easy for anyone to verify it on pen and paper also. But this simulator is made to visualize it fast and to think about many things fast. It automatically generates the DXF files to the scale. It also generates the GIF file. It also generates bitmap files to the scale, such that you can cross verify, you can take the printouts, and there are several other ratios also which you can verify for your own needs. Here is the parser part where you can write the formula, Excel like trigonometry formula, to get the pictures done. Some parts of these things are still under progress. The development process is still going on. I am developing it every day, and it is growing up with multiple features. Suppose a triangle has a oriented line segments also. The oriented trigonometry subject is also coming up with multiple expressive powers are also there, so that we can explain more detailed geometries and infinite series. The summation of the series are also under coverage of these geometric behaviors of its cumulative summation. Let's see how fast we can give you more and more videos to demonstrate the nature of these locked sets and behaviors of these growing geometric insights due to the trigonometry ratio, due to the multiplication of trigonometry ratios, which are ultimately gluing multiple triangles. Thank you.